This is Odum Maths. Today I want us to continue our discussion on limits, calculus, limits and the calculus. And then today we are looking at limits of trigonometric functions. Okay, so that is limits of trig functions. And trig functions, we have the sine, the cosine, the tangents, and the rest. Okay, so let's look at how they behave when limit is being attached to them. So we are going to use the Cartesian plane. And before so this is my y, this is x, the axis, and that is 0, the origin. Okay, so before we continue, let's look at cos 0. So cos 0 should be 1. Then sine 0 is also 0. In doing this, then it means our theta is equal to 0. The angle given is equal to 0. Okay, we said if theta is 0, then cos 0 is 1. Sine 0 is also 0. Okay, now cos 0 here, there haven't been any angular measure, so it's 0. So cos 0 is 1. Now when we move to this side, I'm still using cos. Cos 90 degrees will be 0, but sine 90 is 1. So this place is also sine 90 degrees. Then this place, when you move to this side, cos 180, we are moving this anti-clockwise direction. Cos 180 is negative 1. Then sine 180 is also 0. So we can say that this is also cos 180. Then when we move to this side, cos 270 is will be 0, but cos sine 270 will be negative 1. So this is sine 270, which is negative 1. Okay, so now let's look at these identities. So sine limits of sine x as x approaches 0 is 0, because we said sine 0 is 0. Okay, so as x approaches x, we just put 0 here, and that will be 0. Now, limits of cos x as x approaches 0. So when you put 0 here, we get 1. That is cos 0 is 1. Now let's look at the third one. Limits of sine x over x as x approaches 0 is 1. I'm going to prove this, but we are going to use a calculator to see whether this is actually going to give us 1. Okay, then after we go to the last one. So before we start this, the third one, I want us to look at the proof. Before we start this, let's change the calculator's mode to radian measure. Let's change the calculator's mode to radian measure. So just press shift mode, then you look for RAD. Then you press that one. Then you see on the screen, at the top of the screen, this small r at the top. When you see this, then it means the calculator's mode is on radian measure. If you want to go to the degree measure, it's also when you press shift mode, look for DEG. So you see some small d on the screen. So we are using this one. So shift mode, then you look for RAD, radian. So after pressing that number, the number corresponding to RAD, you see some small r on the screen, at the top of the screen of your calculator. Okay, so now let's go through that. So let's put sine 0.1 over 0.1. So when we see x, we put 0.1, then see what happens. So on the calculator, sine 0.1 over 0.1. I just want to start from here to see what I'm going to get. So that is going to be 0.99834 and the rest. So 41665. Okay. Now let me go to, this is far away from 1, but which is a little bit closer to 0. So let's move towards 0 and see. So sine 0.01, which is more closer to 0 than this one, over 0.01, and then let's see what happens. So that is if x is equal to 0.01. So sine 0.01 over 0.01 is also 0.99983 and the rest. Okay, so if I am to move again, so let me go again. Let me do that one here. That is sine, I am letting x be 0.001, which is more closer to 0 than 0.01. So in that case, sine 0.001 over 0.001. Let's see what we are going to get. So sine 0.001 is more closer to 0 than 0.01. So this is going to give me 0.9999833 and the rest. So you see, as x becomes 0, the resulting or the answer also becomes 1, or also be getting to 1. So it means that sine x over x is 1. Okay. So now let's look at the last one. Here, limits of cos x over x as x approaches 0, they are saying it's infinity. So when we use the calculator, cos 0 over 0, this calculator cannot provide the answer. So it says math error, which is not math error, though the calculator cannot write the answer. So the answer is infinity. That is infinity, very large. So cos x over x is infinity. Okay. Now let's look at some few examples. Okay, so now let's look at these examples. Evaluate the following. Limits as limit of sine 3x over x as x approaches 0. That is A. B. Limits of tan x over x as x approaches 0. And then C. Limits of cot x over cos 2x as x approaches 0. So I'm going to solve these two, and then you take this as an assignment. So you can bring the answer to the comment section. Then I'll look at it and mark. Okay. So now let me start from the first one. Okay, so now let's look at this. Limits of sine 3x over x as x approaches 0. Now, I am going to multiply this. So this is the solution. I am going to multiply this by 1. So that is, I'm multiplying both the numerator and the denominator by 1. And instead of putting 1 here, 1 here, what I'm going to do is, I can decide to put 3 over 3, because we have this 3 here. So this is the same as 1. If I multiply this by 1, I've not done anything new to the question. Okay, so let me now have, this is going to multiply. So that is 3, then the limits as x approaches 0 of sine 3x over. Now this and this also be 3x. Okay. Now look at this. So I have 3, then the limits, 3 multiplying the limits of sine 3x as x over 3x as x approaches 0. Okay, so from here, I can say let y be equal to 3x. So then I have 3, then the limits of sine y over y. Because we said when we see 3x, we should put y there. Okay, and the limits of this as x approaches, as y, because I'm using y, as y approaches 0 becomes 1. So it means that we have 3 times 1, and the answer is 3. That's all. Okay. Okay, so let's look at the second example, that is B. Limits of tan x over x as x approaches 0. So in this sense, we all know that tan x, so tan x, we know that tan x is the same as sine x over cos x. So let me put this here. So that is going to be limits of sine x over cos x over x as x approaches 0. Okay. Now I can rewrite this as the limits of sine x over cos x divided by x as x approaches 0. So that is what I have now. And this can also be the limits as x approaches 0 of sine x over cos x times 1 over x. That is, this is over 1. So when you change this to multiplication, then you turn this upside down to be 1 over x. That's what the rule says. Okay. So I have this also. Now, we can interchange this. So we can this time this is the same as when you change their positions, because we said multiplication is commutative. So I can write the limits as x approaches 0 of sine x over x times 1 over cos x. So 1 over cos x, because I've not done anything new to the question. It's just that I've interchanged their positions. So then from here, let me put limit to each of them. So the limits of sine x over x as x approaches 0 times, let me use multiplication sign here, times the limits of 1 over cos x as x approaches 0. Okay, so we all know from our earlier discussion that sine x, the limit of sine x over x as x approaches 0 is 1. And then here too, cos 0 is 1. So we have this is 1 times, this is 1 over 1. So 1 over 1. And the answer is 1. So that 1 over 1 is 1 times 1 is 1. So that is all about the question. As for the C question, you do it and then put the answer in the comment section. I'll mark it and score you. Okay. Please let me remind you not to forget subscribing. Don't just watch. Please subscribe so that anytime a video or a lesson or a tutorial is given, you can get access to or you'll be reminded. Okay. So please subscribe, like, and share. We are not only, Odumat is not only on YouTube. Odumat is also on TikTok. That is at odum.mat. And on YouTube at odummat2134. On Facebook, it's Odumat or Emmanuel Odum. Thanks for watching. Okay.